Hi guys, welcome to Learning Electronics Repair, another video sponsored by PCBWay.com. I have here some circuit boards made and supplied by PCBWay. This is typical of the sort of board they can make, but bear in mind PCBWay will make boards in various colours, for example, various thicknesses. They can make flexible PCBs, multi-layer PCBs. But I guess this is sort of typical of the sort of hobbyist project that you might want to build. And the great thing is, if you do want to build projects like this, you can go to PCBWay.com. They have a shared projects section. I'll show you that right now. And here we are on PCBWay.com. This is the shared project section. This is very nice because you can look at and search for and build projects that other people have uploaded. You may find something that you're interested in building, or for that matter, you can also upload your own projects here, and the author, that could be yourself, will get a 10% commission if anybody alters your PCBs. Of course, you don't have to use the shared projects. If you want to just order PCBs for your own use, that is very simple on this website. And here is the ordering page. I'll show you just how simple this is. So all you need to do from here is just click onto quote now. Okay, quick order PCB. And then you can add your Gerber file. This is the design file for your PCB. We have one here, for example. So we can open that. Our board is now there, 100% success, okay. And then we just choose, for example, what color we might want this in, the delivery, how quick we want this to arrive. The price will vary depending on where you are, of course. I'm actually based in Spain. So, choose Spain. I have various options. I have things like the global standard shipping. You'll see this takes 9 to 13 days. There's different options at different prices with different delivery times. But if I'm not in a rush, that will do just fine for me. Okay. And you can see I can order 5 PCBs to my design, including shipping, for $9. That is pretty good value for money, yeah? But it gets better if you are a new customer and you sign up an account. Then if you look in the video description to my video, this one, you will find a $5 off discount code on your first order. So in actual fact, you would only pay $4. So that just shows what a good service this is. There's really no reason not to try them. Okay, so that's PCBWay.com. The project I'm building today is this one, a very simple inverter. 50 Hertz inverter, 12 volts in, 220 volts out. We can see that the guy Easy One, this is the author, uploaded a parts list here. It's very simple. One IC, a couple of MOSFETs, and just a few resistors, capacitors, and LED, basically. Yeah. And he then provides a video showing you how to build this, okay? So we can see the video. The guy obviously is mute, he doesn't speak, he plays music, but he can still show us what he's doing here. So you can see he's setting up the project. And then later on, look, it's working there. Yeah, you can see the light bulb lit. So that's the project we're building today. We need a transformer on top of this PCB. I don't exactly have the correct one, but we'll talk about that in a little bit and see if we can test the project anyway. So let's have a look at the one that I've built. And here it is. So we have the IC CD4047BE, okay. We have 2 MOSFETs in there. It's a little hard to see on the PCB now it's populated, but you can see it goes this way round, and we can see the dot which shows the correct orientation for the chip, yeah. This should be a multi-turn potentiometer. I have them, but not in the correct value. So when I get to this situation, the first thing I do is order some for the next time I'm likely to need one. And then I've put a normal one in. So it's a bit awkward. The screw should be on the top, but I can actually just move this. If I think I have it at one end of the range at the moment. Yeah, I can move that, probably use a little screwdriver just to get hold of it. So I can adjust it, and that should be good enough for us to set this up, okay? 2 MOSFETs, electrolytic, that's just on the input across the power itself coming in, okay? Nothing special. And just a few simple components. So that's the built one. This is where we connect the transformer. Before we test this, let's have a quick look at the data sheet for this chip. And here we have the data sheet. It does show the chip, it shows the various pins on here. But I also searched for CD4047 circuit as well, and I actually found this, which is a very simple oscillator circuit. This is basically the same as we have. You can see variable resistor, 100 nanofarad, actually ours has a 10 nanofarad capacitor, 9 volt supply, ours has 12, but it's basically the same. And you can see that this chip only requires a resistor and the capacitor, the chip itself, and we have 3 outputs, output 1, 2 and 3. Now output 1, pin 13, this is the frequency of the actual oscillator. That's the same frequency we find across here in the timing circuit, okay? And then it says that pins 10 and 11 are half the original frequency at pin 13, and the frequencies are inverted. So in other words, when one goes high, the other one goes low, okay? The 3 outputs have a 50% duty cycle. So that tells us very simply how this chip works. Let's go back to the original video, the guy who put this together, and he will show us the schematic, and you'll see it's basically the same as this. And there indeed is our schematic. So we can see he's added a fixed resistor in series with the variable one. That just sets a minimum resistance. So when this one is set to 0, basically, we still have 390k. So basically the minimum resistance between pins 2 and 3 would be 390, and that would increase as you turn the potentiometer. That's the capacitor. Okay, this all looks basically the same. And then you see he has 2 outputs. So he's not using pin 13, but pins 10 and 11 are driving these 2 MOSFETs, and the data sheet told us these are in antiphase. So first one turns on and then the other one turns on, so they just keep switching backwards and forwards. It's half the frequency, okay? That turns these MOSFETs on alternately, on and off alternately, and that pulls power from the 12 volts via the center tap of the transformer to either end, grounds either end, one and the other, and that generates the AC output. Now we're using a square wave to drive this transformer, so I'll be very interested to see what the waveform actually looks like on the transformer. Does it really look square, and does the waveform on the secondary really look square? This is a 12 volt 3 amp transformer. I don't exactly have the right one. I'll show you what I have. So this would normally be the secondary 12012, and this would normally be the primary 220, 240 volt, and you can see we're actually using the transformer back to front basically to step the voltage up. So that's the circuit we have. So we can have a look at the frequency on pin 2, 3 here to see what we have, or on pin 13 for that matter, although it's not used, and we can have a look on the 11 and 12, which should be half that frequency. And according to his video, we need to just change the setting on the potentiometer to get a frequency here on either of these resistors at 50 Hertz. Okay, let's have a go. We know what we expect to find on here then. This is how the original author was setting this up without the transformer attached. So let's have a look. First of all, this is the oscillator. We go to pin 3. Yeah, and you can see it there. So on the scope you can see, and that is actually running at 145 Hertz, 146. Okay, on pin 2, the same. So 144 hertz. Bear in mind that the oscillator runs at twice the frequency of the outputs. Okay, so pin 13 as the output from the oscillator says 149, and then 11 and 10, so 8, 9, 10. Well, that should be an output, and I don't have anything. And that should also be output and have noise, which looks to be about the same frequency as the oscillator. That's not what I expected. Let's just see what the guy does in the original video again. So he's testing the output. He has it set to 50 hertz. Let's see how he's doing that. Yeah, he's adjusting the potentiometer, and he has a scope probe attached. Let's see. Yeah, to the output on the resistor we can see here going to the MOSFET, and he has a square wave on there without the transformer, so I should have the same. Let's have another look. Well, we can see the 2 resistors. I'm actually just looking at this one to make sure that is actually a 220 ohm, but I don't see how this would actually make a difference. Now, with my overhead camera, the color balance isn't very good sometimes, so let's just check under the microscope to see what value these resistors are. This is a gate resistor. Okay. Yeah, 220, 220. You can see them clearly now. Red, red, black is 220, and then the second black means no more zeros, 0 more zeros. Brown is the 1%. So let's measure on these resistors as the other guy was doing, and let's see what we have. But from what I can see on the chip, we don't have any output. I can see pin 8, 9, 10 goes to this end of this resistor. I can see 11 goes to that one, so I can actually see where it connects. I'll actually connect onto the gate of the MOSFET itself. Let's have a look. So that looks like an easy place to get to if I can just get the scope probe on it. Okay. And we can see like little pulses there, but it's not oscillating basically. This one is doing nothing at all. That's strange. Which end of this resistor goes to the chip? Well, I think it's this end. We can have a look. Yeah, that goes to the chip. Third pin up, 8, 9, 10. That's 11 goes on the other one. So we can actually get onto the gate of this if we want to as well, but it don't sort of make any difference. What can be causing that? It's not that like these outputs have like a pull up resistor or anything, because they're connected to the gate of the MOSFET, and effectively the gate of the MOSFET is like an open circuit, certainly to DC. So it's not that like we're missing something to pull the voltage up. I would say that these outputs should go high anyway. Let's just try another chip. I ordered a lot of 10 of these from AliExpress. Let's try another one. Just lever this up. Put another one in there. Certainly inserted correctly. It seems to be slightly, yeah, wasn't quite pushed down, that's all. Right, let's try this one. So power on again. Pin 2, pin 3 oscillating, pin 13, pin 10. Well, it's doing the same thing. I'm not sure why that is, to be completely honest. Let me think. I'm just looking at this simple circuit. So we can see we have pins 7, 8, 9 and 12 connecting to ground, 4, 5, 6 and 14 connected to the power. Yeah. And then outputs. And these are driving these LEDs directly. So firstly, I'm just going to check on my PCB to make sure I have the correct voltage on these two. I could just try tagging a resistor and LED on the two outputs to see if it lights up, but you know, this is so simple to put together. I could put this little circuit itself together on a bit of breadboard and see if that works and test all of the chips. I can't imagine I've got a lot of faulty chips here, but if we put this together, it kind of eliminates anything else. So let's have a quick look. I'll just make a note of the pins that should have the various voltages. So ground should connect to pin 7. Yeah, I made a note. 8 and 9. And then 12. So all those pins go to ground, which should be correct. Let's look at the other ones. So 12 volts goes to 4, 5, 6 and 14. So 12 volts, we can actually get 12 volts here. 4. No, it doesn't on mine. 5. Oh, is this 12 volts? I thought it was. That's good. Let's just check. Yeah, that is 12 volts. So 4, 5, 6 and 14. What? That doesn't make sense because that says I've got no supply to the chip. Oh, on mine for some reason there was a 330 ohm resistor in the supply rail. This. From here to here, and then this is the supply. Why are you supplying it via a 330 ohm? I don't know. 4, 5, 6, okay, and 14. Well, we've measured that. So it is wired as you'd expect. I don't really know exactly why we have this 330 ohm resistor. I'm interested to see if any voltage drop across that actually when it powers up. Let's see. So we powered on. We have 12.58. What's on the chip? 12.53. So there's about 0.05 of a volt or something across this thing. Okay. Yeah, 0.047. We can work out from Ohm's law, we know the resistance, we know the voltage drop, we could work out the current that's being drawn. Well, I'm assuming that isn't what's stopping it from working. So let's put together the little breadboard circuit that we've seen and let's try a few of our chips and see if they work on there. Yeah, that kind of eliminates anything else being wrong here. Well, I've put this together. You can see on the scope there. So I have the scope probe attached to the variable resistor, and you can see the oscillator is running just slower. If I alter the resistor, look, it slows down more, it speeds up more. So it is oscillating. If we go to the output on pin 13, is that changing? Yeah, there's like a square wave on there. There, I've got it now. So Yeah, in fact it's triggered. That's just my scope triggering on it basically. Yeah, you can see it. Yeah, so it's oscillating, but the LEDs are not flashing. One is on and one is off, so it looks like there's something wrong with. Let's try another chip. I mean, that's 2 so far. Okay, power's off. Just change this chip. A little bit awkward where it is, but I'm sure I get to it. I can make a tiny little mark that'll come off, so I just know where the bottom pin goes there. Okay, just to line it up. No silly mistakes here. So out it comes. That's that one. Here's the other one. This is the 3rd one I've tried now. Pins are a bit bent on this one. I have an anti-static mat. I'm resting on it, so I shouldn't really have too much of a problem handling these things. Yeah, the mat is grounded. Actually, that's a good question. How many of you guys have anti-static mats on your bench? And if you don't have one, why? Why do you not think they're a good idea if you don't have one? Yeah, if you do have one, yeah, obviously you must agree with me. And if you don't have one, what harm do you think one would do if you did? Well, that one flashed once and stopped. Waveform still down the scope, just give the scope a chance to refresh. This one kind of like is working but not stable, is the best way I can describe it. It's now oscillating very fast. Yeah, you can see there, just changing the frequency. Okay, switch off and on again. So off. So it goes once and stops. But we can see on pin 13, that's this orange wire, it is oscillating. So that LED should be flashing on and off very slowly, half that speed. It clearly isn't. A little bit faster. Let's try another chip. But none of these seem to work properly. So I think the best we can say is that the oscillator is running at a low frequency. Pin 13 is switching as you would expect, but pins 10 and 11 just don't. That's why the LEDs don't flash. And if we switch it off and switch it back on again, sometimes it comes up in the opposite state. Look, it changed once then, but it still doesn't work. I'm going to try one more of these, but if this doesn't work either, then there is either something fundamentally wrong with what we're doing. But I mean, bear in mind this comes from 2 different projects effectively, and neither of them are working, or there's something wrong with these chips. So yet another one. What does this one do? Well, the same thing. It oscillates slowly, but the LEDs don't flash. My best guess at the moment is to get some more chips from another supplier and see if they work, or at least from another seller on AliExpress and see if they work. But what's your best guess? Yeah, why do you think this doesn't operate as we would expect? Actually, let's just have a quick look at these. So these are the last 3 that I tried. Okay. So, usual trick, put the positive lead onto the negative terminal. We go to diode mode and we look at the readings on the other pins. To be fair, I don't have any known good one to compare with, but it'll just be interesting to see what I find, if it's any difference. So we just got this side, so pin 8, 9. These are the ones that don't seem to work. 10, 11. And they read, well, about 696, 0.696. What's on 13? Same. Okay. So that output seems to read the same as the ones that don't work. So 13, 12, 11, 10. I don't see any difference between them. Look at the third one, but bear in mind none of these seem to work. Yeah, I don't see any difference comparing the output of one to another. Let's just go into the normal polarity, just see what we see. Probably won't see anything. No. Oh, okay, so that one pin 10 does give us a reading. How about the next one? Let's have a look. 8, 9, 10. Reads the same. 11 reads open. 10, 12, 13. This one? Yeah, reads the same. 10, 11, 12. So I don't see any difference between the readings. I just don't have a good one to compare with. But I'm not totally convinced they're faulty. The problem is I can't think of any other reason why this wouldn't work. So, where with this one? I don't believe there's any problem with these at all. In fact, I'm sure this project is absolutely fine, yeah. And when we've built a tester for these chips on a piece of breadboard and it doesn't work as expected, in fact, it does the same as these PCBs, so we know we have output on the oscillator output pin, pin 13. The chip is oscillating as we would expect at a low frequency in this, at a higher frequency on these. But the 10 and 11, the, if you like, inverting and non-inverting outputs don't work at all, and we've tried 4 chips. I would have to say that I'm going to order some more chips from another supplier or another seller either, see if I can find like some have a slightly different logo to these different batch. If they are faulty, it's the first time I've had faulty chips from AliExpress, but to be honest, like, none of it kind of weighs up. We've tried 2 different circuits and the chip doesn't work basically in the same way on both, and we've tried 4 chips and they were basically doing the same, but we've seen the odd one where it will oscillate the output once and then stop. Yeah, so what do you think's going on? Yeah, if you come up with an idea which I think is worth trying quicker than I can get some more chips, then we'll try it. Okay, so over to you guys. Get down there, comment, and I'll see you all soon on Learning Electronics Repair. Ciao for now, guys.